Hi everyone, welcome to AI Crack channel. This is Akash Gungwar and today we'll be studying definite integrals lecture 2. So last lecture we stopped at property number 3 and in this lecture we'll be covering 4, 5 and 6 property. Now before moving further, I'd like to add a point that these 3 properties are the most important in definite integrals in terms of PGDBA or any other examination. These 3 properties are the most important. So do understand them carefully. So let us begin with the property 4. It says as integral a to b fx dx equals to integral a to b f of a plus b minus x. I'll not go into the proofs because these are not really important. I tried to give the proofs of 1, 2, 3 because just to give an idea, but I won't be proving all the properties, right? So just understand that this property is integral a to b fx dx equals to integral a to b f of a plus b minus x, right? So let's look at few questions to understand how to apply these properties and when to apply these properties. So the first question says integral pi by 6 to pi by 3 under root sin x dx divided by under root sin x plus under root cos x. Now one thing I can observe over here is the summation of the limits is pi by 2 and we have denominator as under root sin x plus under root cos x. So even if I do pi by 2 minus x over here and pi by 2 minus x over here, the denominator would not change. So that gives me one good point that if I use this property f of a plus b minus x, then in that case my denominator would not change, but this numerator would convert to cos x. So let's see how this is useful. I equals to integral pi by 6 pi by 3 f of a plus b minus x, that would be f of pi by 2 minus x. So that would give me under root cos x divided by, this would become cos x and this would become sin x. So it would stay sin x plus under root cos x, right? Now let's call this as also I. Both are I actually because of the property 4. And let's add them together. I would get 2i equals to integral pi by 6 pi by 2, not pi by 2, pi by 3. And I'll get in the numerator sin x plus cos x divided by sin x plus under root cos x dx. So this gets cancelled out. So it becomes pi by 6 pi by 3 2i equals to dx. So this becomes a very standard format, very easy format, and you can solve it further. So this is how we have to use the properties. Now one suggestion for you, if you are able to see sin x plus cos x or sin square x plus cos square x and something of this kind of sort in the denominator, and you see the summation of the limits is pi by 2, it can be either 0 to pi by 2, it can be something of this sort, pi by 4, pi by 6 to pi by 3. In that case you have to think of this particular property, right? There is one more condition, I'll tell you afterwards. This was the condition I was talking about. So whenever you see of minus a to a format, in that case the first thought should be of f of a plus b minus x. The first thought. It might be possible that you might not have to apply that property, but just the first thought should come that you have to apply f of a plus b minus x in this particular case, in the pi by 2 case, and also in this minus a to a case, right? So let's see this one. So if I try to apply the property 4 over here, what I would get, this becomes 0 minus x, basically a plus b minus x, that would become 0 minus x. This is 0 minus x, sine of 0 minus x divided by e raised power 0 minus x plus 1 in dx. So we'll be getting minus pi and minus from here because sine of minus x would be minus sine x and this is minus x. So that negative gets cancelled out. This would become x sine x dx divided by e raised power minus x plus 1. So that would be minus pi and this is nothing but 1 upon e raised power x. This would I would take the LCM over here and e raised power x will get to the numerator. E raised power x dot x sin x divided by e raised power x plus 1 dx. Now if I call this as I, this was I and this is also I. Now I'll try to add both of them. So 2i would be minus pi to pi, and if I take x sin x dx as common, x sin x is common, I'll get e raised power x plus 1 divided by e raised power x plus 1. dx. This gets cancelled out and this becomes the standard integral, right? So over here you'll have to apply the y parts and then you can proceed further. Now let us look at this question. In this question as well, I can see minus a to a format, right? So basically the first thought that should come to my mind after seeing minus a to a format is f of a plus b minus x. So let's try to do that. I equals to integral minus pi by 4 and tan square 0 minus x divided by 1 plus e raised power 0 minus x dx. So this would become e raised power minus x, and if we take the LCM, then it would become e raised power x in the numerator. That would be minus pi by 4 e raised power x tan square x. This would stay the same because it's square, divided by 1 plus e raised power x dx equals to, if I try to add both of them, that would give me 2y equals to minus pi by 4. If I'm adding both of them, I'll be getting tan square x times e raised power x plus 1 divided by e raised power x plus 1 dx. So this gets cancelled out and we have got the standard integral tan square x minus pi by 4 to pi by 4 tan square x. Now you can proceed further easily, right? Now one more thing, whenever you see 1 plus e raised power x in the denominator and you see the limits sum is equals to 0, then in that case, the first thought that should come to your mind is f of a plus b minus x. We saw this in the previous example as well, because that would create e raised power x in the numerator, and that would help you cancel out the numerator and denominator after adding both of the integrals, right? So these are the few triggers that should come to your mind on how to use these properties. Otherwise you might not know in the examination what property to use. Now let's look at one more question. Again over here, the summation is pi by 2. Then my thought should be f of a plus b minus x. And also I can see sin x and cos x. That becomes more favorable. So this becomes 0 to pi by 2. And if I do f of a plus b minus x, I'll be getting cos cube x over here. Because sin of pi by 2 minus x is cos x. And divide by sin x plus cos x dx, right? Now this is I and this is also I. I'll add both of them. 2y equals to 0 to pi by 2 sin cube x plus cos cube x divided by sin x plus cos x dx. Now what I'll do, I'll write it as sin x plus cos x sin square x plus cos square x minus sin x cos x divided by sin x plus cos x. This gets cancelled out. This becomes 1. So this becomes 1 minus sin x cos x. Just write in format of sin 2x. Then we'll get the answer, right? This is integral 0 to pi by 2. I'm not solving it completely because the importance is in applying the property and not getting the final answer. The final answer we have gotten in the indefinite integration a lot, right? Now let's talk about property number 5. It says integral minus a to a fx dx equals to integral 0 to a fx plus f of minus x, right? And that would have two implications. Either it would become 0 if the function is odd, because in that case f of minus x would be minus fx, right? In case of fx is odd, f of minus x would become minus fx. So minus fx and fx, that would become 0. In case fx is even, in that case f of minus x would be fx. So that would become 2 times 0 to a fx dx. Now I'm not doing the derivation again over here, but the main thing is to notice that we still have minus a to a over here. Now a little modification in our thought process. If I see minus a to a, then in that case my thought process should be either f of a plus b minus x or this property. I have to use either of them. That would depend on the type of question, right? You can have further triggers like 1 plus e raised power x in the denominator, or sin x or cos x in the denominator, or the summation of the series is pi by 2 or not, whatever. But the first thought after looking at minus a to a is to have this thought or this thought, property 4 or property 5, right? So let's proceed further. Now first of all, what I'll be doing, because this is a very standard integral, because this is a piecewise function, I'll write into 2 parts and that would be it. So we don't really need to apply the properties over here. So what I'll do, I'll just write it separately once. and then we'll proceed further. ln of 1 plus x divided by 1 minus x. Now we know that this is an odd function. If I replace x with minus x, in that case we know that this becomes ln 1 minus x divided by 1 plus x, and this is nothing but ln 1 plus x divided by 1 minus x raised power minus 1. This minus 1 goes here, minus 1 times ln of 1 plus x 1 minus x, right? So basically this is an odd function. So we can apply the property which we studied earlier, the fifth property. But also I said that whenever you see minus a to a, in that case we can also think of property 4, f of a plus b minus x. If you do that over here, that would also work. Let's say this is I, and if I write minus 1 by 2, 1 by 2, a plus b, that is 0 minus x, ln 1 minus x and 1 plus x. Same kind of result, right? That would become minus of ln 1 plus x minus 1 divided by 1 minus x, integral minus 1 by 2, 1 by 2. So adding both of them, that would make it 0. So basically, even if you use property 4 or you use property 5, this would become 0, right? And this is very simple to solve. So basically, from minus half to 0, this value is negative. This value is minus 1 basically. So minus half to 0, this is minus 1 dx, plus 0 to half, this is 0 basically, so 0 dx. So this is the final integral. This integral has been reduced to this integral, right? Now let us try to solve this question. If f is an odd function, then evaluate integral minus a to a and this integral, right? Now in the question itself, it's saying odd function. So basically it's hinting that you have to use property number 5 over here. So let's try to apply the property 5 in this question. That would give me 0 to a f of sin x divided by f of cos x plus f of sin square x dx plus 0 to a f of sine of minus x divided by f of cos of minus x plus f of sine square minus x dx. Now you can see that f of cos of minus x would be cos x. So this stays cos x only, and over here as well, sine square minus x would be sine square x. So that also stays f of sine square x. Now you can see that the denominator is same for both these entities, right? Now in the numerator over here, sine of minus x would be minus sine x. So that would become 0 to a this one plus integral 0 to a f of minus sine x. Now f is an odd function, so f of minus sine x would be minus f of sine x, right? That would give me minus f of sine x dx divided by f of cos x plus f of sine square x. Now if I'm trying to add both of them, numerator becomes 0. Your answer would be 0, right? So this is how you had to solve this particular question. Now let's look at property number 6. In this case, it says 0 to 2a fx dx equals to 0 to a fx dx plus 0 to a f of 2a minus x. Don't get confused in these kind of properties. Try to write it down 2-3 times to get a hold of these, changing of limits using 2a minus x, a plus b minus x, a minus x or minus x, whatever. But try to write all these things 2-3 times on paper so that you get a hold of these properties. Again, I'm not doing the proof over here. So let's directly jump into the questions to see how it is being applied. So I equals to 0 to 2 pi sine 4x dx equals to k times integral 0 to 2 pi by 2 cos 4x dx. Find the value of k. Now, the biggest hint you can get to apply this property is generally in such cases, the limits would start from 0 to some even number, 2 pi, 4 pi, 8 pi, 16 pi, something of this sort. If you are getting these kind of limits, then most probably you have to apply property number 6, right? So in this case, let's try to apply it. So I would become 0 to pi fx plus 0 to pi f of 2a minus x, right? That would become sine raised power 4 2 pi minus x dx. Now this is an even power, so that won't make a difference. So it would eventually become 2 times 0 to pi sine 4x dx. Now similarly we have even power still here, and if I apply the property once again, in that case we'll be getting 4 times 0 to pi by 2 sine 4x dx. Now we have the answer in the format of cos 4x. So what we can do, we can use a plus b minus over here. So a plus b minus x, 4 times 0 to pi by 2 sine 4 a plus b, that is pi by 2 minus x dx. So that would give me 4 times 0 to pi by 2 cos 4 x dx. So basically k equals to 4. So in this particular question, we applied property number 6 and also property number 4. So we have seen application of two properties in one single question, and that is the maximum difficulty kind of question you can get in the PGDB examination. They won't be asking you multiple applications, more than 3 or more than 4 applications of properties in one single question. They can ask you maximum 2 application of properties in a single question. Now let's look at this example. We have 0 to 2 pi sine 100x dot cos 99x. Again, I can see this trigger 0 to 2 pi. So basically, my first thought should be to apply property number 6. That would give me 0 to pi sine 100x cos 99x dx plus 0 to pi sine of 2a minus x. That would be sine 100 2a minus x, basically sine 100 2 pi minus x dot cos 99 2 pi minus x dx, right? So this is again even power, that would eventually become sine 100x only. And we know that in case of cos 2 pi minus x equals to cos x only. So this and this both are same. So this would become 0 to 2 times 0 to pi sine 100x dot cos 99x dx. Now we can again apply, because we have 0 to pi. Now you can again apply the property. That would give me 2 times 0 to pi by 2 sine 100x dot cos 99x dx plus 0 to pi by 2 sine of pi sine 100 pi minus x dot cos 99 pi minus x dx, right? But over here we have even power in sine, so that would eventually become sine x only, sine 100x. But over here we have odd power, and we know that cos of pi minus x is minus cos x, so that would become minus cos 99x. So this and this gets cancelled out, so answer is 0, right? Now let's look at one last question. This is actually one over here, it's not two. Okay. Now again, I can see 0 to 4 pi over here. So we have that kind of trigger that we have to use property number 6. So let's try to do that. 0 to 2 pi, and I can see even power, no change. So 2 times dx cos square x 1 plus tan square x, right? Similarly, again even power, I can do 0 to 4 times pi, 4 times 0 to 2 or 0 to pi dx by cos square x 1 plus tan square x. Again even power and 0 to pi, I can do the same thing once again. 0 to pi by 2 dx divided by cos square x 1 plus tan square x. Now what will happen over here? Now if you try to do it further, it would become cot and it would become sine. That won't make a difference, that wouldn't make a significant difference, right? And we cannot solve it further with the help of properties. Now you'll have to apply the indefinite part. So this cos square x become sec square x, you have to take tan x equals to t, and then it becomes the tan integral, right? So you have to do that. Now you must be thinking that why I didn't do this thing earlier in this case, because in 0 to 4 pi, if I had to do this kind of substitution eventually, why I did these steps? Because in this 0 to 4 pi, tan x is not continuous. It becomes discontinuous at pi by 2, right? So in many other locations, it becomes discontinuous. So we cannot use the property directly over here. We have to reduce it to 0 to pi by 2, and then we can use this particular stand format, right? So today's lecture was still here only, and in the next lecture we'll be covering up property 7, Leibniz rule, and limit of a sum, and that would be the end of definite integration. So let's meet tomorrow. Thanks for watching.